Okay, we'll kick off. Um, Thanks everyone for joining today. We're going to be talking about feature stores. Specifically, at the end of this, we will have built a training set in Featureform. We'll train a model using Sagemaker. We'll deploy it on the Sagemaker endpoint, and then we'll serve some features to it. So you can see how the whole thing kind of works end to end. We'll start by talking about a bit about what a feature store is, how it works, what the value props are. I'll throw in a ton of memes to make it fun, make it worth your time. And at any point in time, if you have any questions, um, please feel free to throw them in the Q&A. If you're on Zoom, if you're on LinkedIn or Twitter, you can just leave a comment, and Shab and our team will be keeping an eye on them, and we'll share any of the questions here so I can answer them. There's going to be a lot of kind of like natural points throughout the presentation where I will be able to answer any questions you have. Great. Well, let's get started. So if I can figure out share my screen. There we go. Okay, close my chat. Let's do this. Okay, so today, feature stores in practice, we're going to train an end-to-end model with Sagemaker and Featureform. We'll actually be using Spark here, running on EMR to train, and we will deploy the features to Elasticache, Redis, to actually serve. And those options are just kind of arbitrary. I just picked three for use in this webinar. We have a lot of webinars where I switch up what we deploy. I switch up a little bit of the content. Like last week, we had one using Databricks and actually serving training using MLflow and then deploying it on an endpoint on Databricks. So keep an eye out if you have any specific asks for any stacks that you'd like to see, let us know, and we can see if we can get that going. So we'll start with what is a feature store. So features are inputs to models. So I guess the first question, if you want to know what a feature store is, you should probably start by asking yourself what is a feature. And a feature is a very overloaded term. It means different things to different peoples and different domains. For the purposes of this presentation and feature store specifically, you can think of a feature as just an input to a model. Now that's kind of vague. Some examples just to kind of ground that idea would be a user's favorite song in the last 30 days, a store's top selling item in the winter, average price of all items in the catalog. These are all examples of features. Another way to think about it is typically in data science, you'll start with a raw data set. You'll kind of pull out signal from it. That pulling out signal, the signals are features, and the process and the steps to pull that out is feature engineering. So where does a feature store fit in? Well, a feature store has five things it does with regards to that feature engineering process. It facilitates deployment, and we'll get into what that means. But generally, the experimenting and building and coming up with features and the actual process of deploying those features tend to be very separate. Oftentimes are written completely differently by different teams and different pipelines. It enhances collaboration and organizes experimentation. Those things kind of tend to go hand in hand. Enhancing collaboration means that other data scientists can share and reuse and work together. And organizing experimentation is just for yourself to be able to keep yourself organized, use versioning, have a lineage, all the things you would need. Now, it's hard to enhance collaboration without organizing experimentation, so that's why they happen together typically. Increasing reliability. Once features are deployed or as you're building features, you want to make sure they continue to work as they were working when you trained the model. This means things like lots of different types of monitoring, anything from data drift to just uptime. And then finally, depending on the industry you're in, preserving compliance is another key value prop. So if you are in a regulated industry, you might have different rules on which models are allowed to talk to or allowed to use which features, which users and data scientists are able to see which data sets. So feature stores kind of preserve compliance in the feature engineering workflow. So let's start by talking about facilitating deployment. By first talking about how we build a feature typically. So typically, what I'll do. So if I want to do feature engineering, I'll download perhaps a sample of the data, or I'll work directly on wherever the data is stored. I'll work in a notebook, and it's just a lot of analysis. Like I'll be looking at the data, I'll be looking at features, I'll come up with hypotheses, I'll test them. They'll either be right, I'll go deeper, or they're wrong, and then I'll continue to try. It, unlike software engineering, which I think is very linear, I was originally trained as a software engineer. Data science is much more of a science. Like the science part really does come out. Like there's a lot of hypotheses and testing and throwing things away, where engineering, you're building. But once we're finished, like once I come up with some interesting features in my notebook, deploying into production is a ways away. It's very hard. It's very different. Like the deploying to production is an engineering problem, and finding the right feature is a science problem. What ends up happening a lot of the time is I see one of two things. One thing I see is on the left here, where the data scientists themselves end up writing Airflow jobs, PySpark scripts, sometimes writing in Java, like deploying these features themselves, which is a completely different, call it problems, or a different skill set than the skill set of traditional data science. The other thing we see, which is the button on the right here, is data scientists just come up with a notebook, they come up with an idea, they train a model in their notebook on some sample of data, and then they pass it to the data eng team. And the data eng team's job is to get it into production, or an ML eng team. Both cases have obvious drawbacks. With the two-team approach, it's this almost like a translation step. You take it as a data scientist, the way you think, the words you use, the concepts you have are completely different from what ML engineers have. And that translation is painful, it takes a lot of time, and it's very error prone. Also, as a data scientist, you don't really control your own destiny to an extent. So you can come up with this model, and then it's the data scientist or ML engineer's job to get it there. And oftentimes what we'll find is that data scientists will even build things that are impossible to really get into production. And so it's kind of more of an exercise than an actual value add to the company. On the left side, the problem of doing Airflow and PySpark jobs is similar. Is that do you, as a data scientist, like these aren't the things that you are really good at or really focused on, probably. There are always exceptions, but a typical data scientist may know how to use Airflow and will know how to write PySpark, but writing those jobs to be highly available, to monitor them, to handle all the potential error cases is kind of typically out of scope. So why is there such a difference between experimentation and production? Well, there's many different things, but one is the idea that, especially for models that are interactive, which means that they're always running, so you can always hit them with request. You kind of need to write three different types of features for them, or there are rather three different types of features that you might feed into them. The most common one, or the one that most resembles typically what you did in experimentation, is batch. So in this case, you'll write a batch job. Now, if you're working in pandas locally, you might have to translate to PySpark. It's similar, but different, and different in ways that can really screw you up. Even things like ordering null is different in pandas versus PySpark. But looking at that, so how this works is batch features are features that can be pre-processed. So for example, if you want to know a user's favorite song in the last 90 days, you can process that at request time, right? Like you can, every time a user makes a request for a recommendation, you can take all of their songs and process and generate their top song. But if you're Spotify, think of how many recommendation systems run on every single page. The idea of processing all of the user's data every single time they want to do something just to feed it into an expensive model anyway, the time to do that and the actual costs don't make sense. So in those situations, we'll typically pre-process the features. Now, there's two ways to pre-process them. You can pre-process them in a streaming fashion. So every time a new event comes in, you process that event and then you update the inference store. It's like a cache of the value of each feature. Or you do it in batch. If you do it in batch, it's typically, like I said, simpler because it most resembles what you were doing in experimentation. You typically will do on some sort of schedule. So you continue to run those batch jobs on the schedule. In streaming, it will be more fresh. Fresh means that it's like more up to date. Like the value of the feature is more likely to be, it won't be exactly what it is. It's near real time. It's not real time, but it is very close to what the most fresh value of that feature would be. But the problem with streaming is it is complicated. There's a lot more error cases, a lot more things and nuance you need to think about. Events can come out of order. Events can come very late. Events can be dropped when you're creating a new feature. You need to backfill it. There's a lot of problems that arise in streaming that don't happen in batch. So oftentimes people will do batch unless they have to do streaming. Now there's a third type of feature. These are on-demand features. On-demand features are features that cannot be pre-processed. For example, if you want to write a spam detection model and it decides if a comment coming in is spam or not, you can't pre-process the features that have to do with the comment itself, the text in the comment, because you won't have that until the time of the request. But all the processing you do on that text are still features. They still go into the model. So those are on-demand features, features that run at request time. So that's one core piece, the ability for a data scientist to be able, so what Featureform does to facilitate deployment is the data scientist writes their feature once. They can use that feature. It's lightweight enough to be able to be used in experimentation. You can convert it to a data frame very easily. You can play around with it. You can do whatever you need with it. At the same time, deploying it is very simple. Like Featureform will handle scheduling for you. You just give us what schedule you want. It will handle monitoring for you and all the other components you would need to properly deploy the model. The next piece is enhancing collaboration, organizing experimentation. This is literally all I did is put together 5 memes to really make you see and feel what I'm talking about here. The general idea, so for collaboration, you need documentation. You need to know what the features are. You need to know how they're built. You need to know their lineage. You need to know if there's different versions of them. You need to know what models are using them to really understand what a feature is. Because of the tool sets we typically use today, we don't really have any of that. And so a lot of what ends up happening is people manually documenting these features. Now, I guess you can ask yourself, do you actually document your features and update documentation every single time you create a new feature or update a feature? And the answer is typically no. So a lot of very easy memes to write based on this because I see it all the time. Another thing I see a lot with regards to this, organizing experimentation, is the fact that even though we're getting our features in production, the process of getting there creates a lot of trash, like untitled notebooks, DF finals, features table v7, copy feature to redis.shell. ad hoc Spark submits, ad hoc YAML files, and no documentation. If you've ever looked at a training set and wondered or tried to refigure out how did I build this thing, you'll kind of know what I'm talking about. It's even worse when you're working on a larger team and maybe you're inheriting someone else's project and you're trying to figure out what they did and why they did it and what these features are and where the data pipelines are. And in a lot of those situations, it's kind of a fool's errand. There's no way to do it. By the way, like I said, if there's any questions as I'm going through this, I know I'm going relatively fast. Feel free to throw them in the Q&A on Zoom. And if you're in LinkedIn or Twitter, you can just leave a comment. Okay. Increasing reliability. So with interactive models or models are always on, the feature values are typically constantly changing. They're getting updated. And there are new features getting created, there's new data points, etc. That means that the feature values and distributions are kind of alive. Like they move, they change, and they drift. As well as like the infrastructure goes down, things change, upstreams change, and all that stuff may or may not affect the model. And the worst, actually, like sometimes I almost prefer it to like break the model because then I can immediately catch it and fix it. The worst is when it kind of degrades the model, like the model does 5% worse than it was. These sorts of situations happen very often. And sometimes they don't get caught for months. Just like the model just started doing worse, people just kind of accepted that it was doing worse, and that happens, and I thought it was part of normal fluctuation. And then it wasn't until it was consistently doing worse for a while that someone looked into it and realized that, hey, this feature values changed quite a bit, and the model needs to be retrained, or the feature logic needs to change. That means when you deploy a feature, you need to be monitoring it. Not just there's three different types of drift that people monitor for. One is data drift. Data drift is just the table changing changing its distribution. There's feature drift, which is actually different. So if I have you know, let's say 1 million users, and the average age of my users is 40, and then that average changes to like 30, then the data has drifted. But if my model, the specific model I'm using, typically serves for people who are over 65, then even if the data drifts, my feature might not drift because I'm still kind of sampling the users and the distribution of the values that I sample hasn't changed. So if you look at it from that perspective of what's the feature values going into the model, what's the distribution of that, and is that changing? That's feature drift. And finally, there's model drift or concept drift, which typically looks more at the output of the model to also see if that's drifting based on the inputs. If that's happening, it typically may signal a retrain. But with a lot of companies that we've seen and worked with, they don't have that monitoring for features. They might have data monitoring, but that's not the same. And it can actually screw you up in a lot of different ways. It's better than nothing, but still not really feature drift. Concept drift is useful, but concept drift is typically after the fact. It means the model has now officially degraded. Feature drift is great because it's oftentimes proactive. If you see a feature drifting, you may oftentimes catch a change before the model drift even kicks off because it might have a small enough effect on the model, and you can fix things before it kind of gets out of hand. And finally, there's preserving compliance. Now, preserving compliance, I won't really get too deep into in this talk, but you can imagine that for a lot of companies, a lot of large corporations, lots of the data they are doing machine learning on is heavily regulated, has PII in it. Some of it might be in Europe and has a different set of rules. Some of it might be in California and have one set of rules. Some of it might be in somewhere else and have, another set of rules or practically no rules. But preserving compliance, making sure as a data scientist that I don't have to go talk to legal all the time whenever I want to do something. Kind of making compliance be a core piece of the function. Like when I'm building features, if I don't have access to a data set, I shouldn't even see it. And if I do, I should see it. If I'm working on a specific model and that model can't access certain columns from a data set, I shouldn't see those features. Maybe I see them grayed out or those columns. So having the governance and compliance process be built into the feature engineering process makes life easier. As a data scientist, you just work as you're used to, and then the guardrails are already up. And for legal and everyone else, they can be happy knowing that no one's going to get sued. Okay, let's talk about Featureform. So the goal of Featureform is a framework. It's in Python, and it's built to define, manage, and deploy and serve your ML features. The main API is a declarative API written, again, in Python. It allows you to define your features not as tables. Like a lot of people think of features as like a feature table and output, but we think of it as the logic. Like what's the feature definition? It also comes with a dashboard so that things are searchable, reusable. There's monitoring in it, there's alerting in it, etc. So the Featureform kind of bubble includes resource repository, a collaboration tool, a monitoring and alerting tool, and governance, as well as orchestration, all for the feature pipeline. The orchestration, we call ourselves a virtual feature store because Featureform itself never actually stores your data or runs a compute on your data in the sense of the raw data. What Featureform works is at the metadata layer and then orchestrates your infrastructure layer to build the features, put them in the right place, keep them up to date, handle errors, alert, do governance, etc. Finally, the whole point of building features and training sets is to train models and perform inference in production. And so Featureform has very clear and easy APIs to do that. So that's kind of the over holistic, like what is Featureform in a nutshell. Another maybe perspective to think about it from is as a data scientist, you're writing your logic. You'll be working in a notebook or just anywhere. You'll be writing it in PySpark and Python and SQL, whatever you're using or used to using. You will define those things, or you will write that stuff in the Featureform framework. Featureform will store that as metadata. It will create your lineage. It will do versioning for you. And then it will orchestrate your engine. In this case, of this example I'm going to show you, it'll be orchestrating Spark and Redis on AWS. Featureform itself isn't just from your perspective as a data scientist, it's a framework, but in reality, it's actually deployed on Kubernetes. And that allows us to run a lot of different jobs. So things like copying, checking, validation, certain types of transforms, we can do in Kubernetes. So there's a lot of like glue and like little kind of pieces that are missing and stubs that are missing in Airflow and Spark and other things that are required for feature engineering and for building training sets and building features. But Featureform does automatically for you. Just give us the logic and we'll run the feature pipeline for you. This is a bit unique. There are three types of feature stores, three different architectures. When a lot of people hear feature store, they think, okay, I understand. It's where you store your features. And that's the approach, actually, we call it a literal feature store that many products have taken. There's an open source feature store called Feast, which actually officially is unmaintained as of yesterday. That was popular, that kind of formalized this architecture. And a lot of the AWS, Databricks, etc., kind of used this concept for their own feature stores. Now, the way to think of this is you're still running your own data pipelines, you're running your own transformations, and then you output the feature table, the final thing, into the online feature store or into the literal feature store. Now, let me show you why that can be an issue. So I'm going to stop sharing for a sec so I can make sure I don't show anything I shouldn't show. And I'm going to show you what the Databricks feature store looks like. Um, just to give you a sense of comparable. So in the Databricks feature store, once it loads, okay, there it is. So I'm going to share my screen again. Okay, so in the Databricks feature store, so in Databricks you have this sort of idea, and you can click. You have many different featured tables. The featured tables have features in them. Again, this is a literal feature store. So the way the feature table works is that you'll build your feature and then you'll write a table more or less into the feature store. And then it will kind of keep track of the columns and it will call each column a feature. Now here's some issues. One is if I look at any feature, customer account balance, I have no information here. This is all I get. I don't know what this thing is. If I want to collaborate on it or remember what it is or use it or see what's happening or monitor it, I don't have any of that. All I know is that there's this table, which I've just designated to be a feature table, and I have a column, which I've just designated to be a feature, and it exists. That's kind of all I get. The other problem is that it doesn't really have the idea of a label. Like, is fraud in this case is a label, but there's no labels in this type of feature store. It just every column is a feature. And there's one column which is the primary key, and that's it. So that's kind of the approach that literal feature stores take compared to something like Featureform, where I have to sign in again. Something like Featureform, if I look at, let's say, balance, and I look at, I don't know, let's look at percent balance. Let's look at a different version of it. Let's look at this version. You can see that I have a description, I have the owner, I have the provider, I have pretty much where was this thing run. I have the source, which is like what built this thing. I have the actual logic. I can preview it, so I can see like different columns in it. I can follow this to kind of get the lineage. I can see what training sets it's a part of. I can look at this and say, oh, okay, it comes from here. What is this thing? Where did this come from? What's this preview? I can really understand what the source is and what the data sets are and what the features are, all the way from kind of the whole definition. So that's one piece that really separates a literal feature store from the other two kinds. The other two kinds are the physical and the virtual. The physical, some people call a feature platform because, like I showed you, it does a lot more than just store features. The difference between a physical feature store and a virtual feature store is that a physical feature store has its own engine. A Tecton has an engine that runs your compute on. So if you use Databricks, you would actually have something next to Databricks that would compute your features, and it would store your features, and it would do all of the logic and storage on its own infrastructure. So it's very heavy in that way. It's kind of replacing everything. And a lot of internal feature stores look like this. Like Uber built a feature store that looks like this. Airbnb's feature store looks like this. On the other hand, there are virtual feature stores. Well, virtual feature stores, which is, there's only one. We kind of invented the idea. We came up with this idea of what would happen if you took a feature platform or a physical feature store, but kind of disintermediated the actual infrastructure. So that rather than having our own like compute engine, we would just use whatever you use, whether it's Snowflake or Spark or Postgres, we don't really care, or all of them. However, use your inference cache. So like use your Redis or your Cassandra or your Dynamo. And all we're doing to an extent is taking this infrastructure and providing an application layer. Pretty much make all this stuff work together like a feature platform, which means having a single source of truth for features, being able to define transformations, features, labels, training sets, infrastructure, adding search and discovery, versioning, lineage, governance, monitoring and alerting, etc. An ability to serve features for training and inference, doing point-in-time correct joins if you're dealing with time series data. All the nuances and everything that you would need to make your infrastructure work like a feature platform is what Featureform provides. Just that and nothing else. We're not trying to replace the infrastructure. So those are the different types of feature stores. And again, if there's no questions so far, I was aiming to spend the first half just giving you concepts, spending the second half actually showing you code in the project. So today, so this is probably looks overly complicated, but let me start at the top left. So at the top left, there is me. That's an icon representation of me or any data scientist. I'll be working in a notebook server that's run on Sagemaker. So the notebook server is oftentimes it's like where everything's done. I run my training jobs from there. I run my models from there. I deploy things from there, etc. In that notebook, I will be interacting with Featureform. I'll be creating new features and transformation. Excuse me. Featureform will save those, will make them searchable, and it will also orchestrate some of the infrastructure that I provision, which includes Spark, it includes Redis, and it's running on an EKS cluster, and it will actually run EKS pods itself as needed for different jobs that need them. Cool. So that's kind of step one. Step one is I will define my training sets and my features in Featureform. I'll also read from Featureform to reuse some of the things that are already in there. Like my Spark is pre-configured, my Redis is pre-configured. I have some data sets that are pre-configured. And so this would be equivalent of like a different data scientist having built that or used it. And I can just use those rather than having to start from scratch. Then once I build my training set, Featureform will orchestrate it. I can actually get those training sets as data frames, both as pandas data frames, as Spark data frames, but they're also stored. In this case, I registered S3. So it will actually store the data set in S3, which is how SageMaker works for training. So then I can train off of a path in S3 to train a model. And so I will run that training job out of my notebook and it will run somewhere else in SageMaker. Then I'll have a trained model. Finally, I'll take that trained model and I'll deploy it as a endpoint. The endpoint can then serve predictions on demand. So whenever like I have a new user that needs it's a fraud detection model, like I have a new transaction, I can check if it's fraudulent. And so any service can make a request to that to Featureform to get the features, and then make a request to the model with those features to get a prediction. In this example, rather than running like a whole service to do that, I'm just going to, from the notebook, manually call client.features or get features for a random user I just arbitrarily picked, and then I'll do a prediction based on that user. So I know it was a lot, but I'll go through it. Okay. So let's start here. So I'm gonna zoom in because I know it's a little small for Zoom. Okay. So the first thing I'm gonna do is, in this case, I have Featureform running. I have an enterprise version running. Featureform is open source, so everything is open source except for governance and stream processing. In this situation, everything we're doing is actually possible to do in the open source. It's just the sandbox I'm running happens to be an enterprise sandbox. I'm gonna get my I'm gonna install the Featureform client. Gonna set up some of my stuff, like get my account ID, the region, the IAM roles, all the stuff I would need to work with SageMaker. This is in SageMaker, by the way. I should make that clear. This is a notebook that is running on an instance in SageMaker. So this is SageMaker notebook instance. The first thing I'm going to do is create a client. And the client, I'll point it at internal sandbox at featureform.com, which you could go to if you wanted to. You won't be able to get in because you'll need to log in. But you will, you would see something like this. Everything in Featureform is version. One thing that we kind of do similar to MLflow is in a notebook, it might be more relevant or useful to just set the generic kind of, this is the default version of everything I create so that they all have the same and they're all kind of grouped together. So what I'm doing here is everything I create in this notebook will have the version internal sandbox Simba. If you don't set this and you don't set a version for anything, it will actually auto generate one based on the timestamp, which is often like a pretty good default. And you can always override it. Okay. So I'm gonna be taking some data sets and transforming them. So the first thing I want to, and I should just run all these things again. So the first thing I want to do is I'm running some of my transformations on Spark, and I am going to store them on, or store my features for inference on Redis. So I've already in feature form. So I have materials, or I have, let's call it like Redis. So I have Redis internal sandbox. I can see that Redis internal sandbox exists. I'm hiding the configs and stuff in this example, but you can see the configs. You can see what features exist in them. You can see all kinds of other stuff that would exist in it. So I retrieve my Spark and Redis. They're essentially like retrieving the metadata of them so that I can use them to build things. So the first thing I'm going to do is I have a source or a data set that already exists in Featureform. It's called transactions, and the variant, which is like the version, is called clean. So again, I could go into Featureform and I could look up transactions clean. I can spell. If I go transactions clean, you can see what transactions clean is. It's just doing a very basic timestamp operation to make the timestamps good. You could preview it here. In this case, what I'm doing is I'm getting it, and then everything in Featureform can be converted to a data frame. So in this case, I'm getting it and then converting it to a data frame, or not, because why not? My access token is no longer valid. Okay, here, I'm gonna just authenticate real quick, and then I will be right back on it. 1 second. Sorry, y'all. One moment. Sorry. Bad timing. Okay. Okay. Oh, it's really making me do the whole thing. Nice. It thinks I'm a bot. Okay, authentication is successful. Exit there. Okay, let me just do this in the notebook. Okay. Boom. Boom. Run that. Okay. Okay. Let me just make sure that works so I don't start sharing again. It's not gonna work. Okay, now it's working. Okay. Um, sorry about that. Let me get you all back into my screen. So I'm gonna share my screen again. Okay, so I'll run this one more time just to show you. So I apply this run. I get the source, which is transactions clean, and then I convert it to a data frame. which I can do with anything. I can actually convert it both to, if I just do client.data frame, it's pandas. I can also convert it to a Spark data frame if I wanted to by providing the Spark context. And you can see what this data set is. I'm really zoomed in, but there's a lot of columns here. Cool. So data sets are great, but typically, when you're learning data science, like we just pretend that we have these perfect CSVs that have the exact features we need in them. That never happens. We always I can't even remember if I've ever had that happen. In every situation, you're gonna take that data set that you get, clean it up, transform it, build the features, and pretty much pull out the signal that you need. One example would be this percent balance. So maybe a feature would be I want to take the account balance and divide it by, or sorry, take the amount that was in the transaction that was made and divide it by the balance to get a percentage of the amount to the balance. Now there's a kind of condition here where if the balance is 0, right, then you end up dividing by 0, which is bad. And so if it is 0, I just make it 100%, which is not great. But again, feature engineering is a bit of a messy process. So you can see here that this code is just PySpark's code. With or without Featureform, this is exactly what you would write. What Featureform does is you annotate that code with a function. You annotate the function. You specify, hey, this runs on that Databricks thing that I got earlier. This is like a Featureform object. It's not some Databricks object. You specify the inputs, which in this case is that source I got, transactions. And that's it. And then you apply it. And once it's applied, you can call client.dataframe. Client.dataframe will implicitly apply if you don't apply it. And you can call client.dataframe if you want to turn this thing into a data frame to make sure it worked, make sure everything looks okay, do any sort of analysis, print out a graph, whatever. So I can do that. You can see here that it status is ready. It's instantly ready because I pre-ran this stuff. Yeah, and then you can get the data frame and you can see that there's that new column right here, which is balance percent. Now, some transformations are far more complicated than just divide. Like I might be curious to have so this is a windowed function. So you can see it's rows between pretty much the last 30 things I have. So in the last 30 items or transactions the user made, what's the average? And so the user might not have 30 transactions, in which case I just want the count as well. So I add 2 columns to the data set. You can see here, add 2 columns, meaning count, means the average transaction in the last 30, counts the number of transaction number is less than 30. So I can run this as well. Again, it's going to happen instantly because I pre-ran it. And then you can see the data set again. Now I can look in Featureform's dashboard and I can find window X. And I can see the description and I can see the code and I can see who built it. Cool. Now, in that window ags one with the average transaction amount in the last 30, that's changing constantly, right? Like every time there's a new transaction, that amount changes. But when I am building a training set and there's a fraudulent transaction, I want to know what was the average transaction, that amount, that feature I created at the time of the fraudulent transaction, right? Like I want to have a point in time correct training set, which means that for each label, I want to know what the features values would have been at that point in time. This is especially important when I'm creating a new feature. It's almost like back testing. Like I need to go and generate that feature for historical values and then properly zip together with the label to make sure things happen correctly. Now, a data engineer who doesn't know anything about ML or data science, it's going to take a while for you to explain that to them, and they're likely to screw it up. With feature form, you just specify your features and labels, specify the primary key, if there is one, the value, and then if it's a time series, you specify the timestamp column. You can specify the type if you want, and then you can specify for features, you can specify the inference store. So in the inference store, right, we don't want the values of historical features because in inference time, we're never going to be like, what was the feature of balance 4 years ago? In the inference store, it's like a cache. Like I want to know what the value is now. And so what Featureform will do is it will materialize the most recent value of all the features into Redis, and it will maintain the historical values. And when you build the training set, like I do here, and I specify the label and the features, it will properly zip those things together into a point in time correct training set for you. So it will get the historical values of those features. So I can do that. And again, these things are pre-created, so it'll go really fast. I think, yeah, they're all ready. And voila, I built my first training set in Featureform. Now I can use it. So all I do is I call client.training set. I specify the name and the version. And I can get it as a data frame, both pandas and Spark. I can get it as mini batches if I want to stream. However I want to do it, I can do that. And so I can go ahead and get this thing. There's like a million rows, so I have to download those million rows. It takes like a moment. Now, the other cool thing you can do is when you're calling this, you can specify a model parameter, which is just a string. When you do that in the dashboard, if you go to models, you can actually see what features and what training sets this model uses. Now, again, we don't know what the model is. We don't store the model. It's just a string from our perspective. But if you use this in conjunction with the rest of your infrastructure of MLflow, et cetera, you can build a lineage all the way from the model to the data set. Now, after this training set is done, the next thing I do is kind of configure Sagemaker. So I'm just specifying where do things go, all this other stuff. Once I set that up, those pipelines, I can train my model. So the way I train a model is in SageMaker in the notebook instance, I specify the instance type. So I'm just using a probably overly large instance. I get XGBoost. I set some hyperparameters. And then I create a training job, which in SageMaker, you create an estimator and then you fit it to the training data. So yeah, straightforward. I could also set this instance count to a different number if I want to do it distributedly. And after this runs, it creates, so you can see I ran it before. I'll spare you waiting for a model to train, but it will create a model. In which case, I can then serve it for production very simply. I just specify an endpoint name. I specify the instance type, which is a slightly smaller instance, serializer, number of whatever, all that stuff. And I deploy them all. So very straightforward, very easy. And once it's run, I can then call, and in this case, I'm just calling it manually. And usually I wouldn't do this from like a notebook. I would do it from like whatever service you're using. When a user makes a transaction, maybe there's some transaction fraud server, it will call client.features. It will specify the features that it wants. It will specify any parameters that are relevant to those features that come at request time. So the transaction amount comes at the time of the request. It will specify any entities. So in this case, it's a user entity. So this is just a random user I picked. And that will give you a set of features. And then I can use that with the predictor endpoint to create a prediction. Now, this protector endpoint, the way it works is it returns a string for some reason, and the SageMaker, and it it returns a number, which is the percent likelihood of it being fraudulent. Um, and I just kind of chose a 0.5% or 50% likelihood. If it's more than 50% likely to be fraud, it's called fraud. And I print it out. And in this situation, it's not fraudulent based on this random data I arbitrarily picked. The one thing I didn't show, just to kind of cap things off. So I have a feature that I trained on called percent balance. Now, percent balance, right? It's not, it's the percentage of the transaction divided by the balance. The problem is, even though I have the balance, I won't have the transaction amount till the time of the request. In training, I had historical transaction amount, so it's very easy to build. But in production, I had to define an on-demand feature. And the on-demand feature, I specify that there's a parameter, and I divide here. I apply this, it creates a feature out of it. Again, this feature is searchable. There's lineage, you can get distributions on it. And then when you serve, you just specify on-demand percent, and it will automatically run that platform function, that final kind of last mile transformation for you. So that's it. So in this workshop, we went, and thanks to everyone who for sticking around. Looks like pretty much everyone stuck around. So hope that means this was useful. And yeah, this was an example of building a training set using Featureform, and deploying a model on SageMaker after training it. Featureform is open source. You can just look up GitHub Featureform. And we have a Slack channel that you can always ask questions for. If there are any final questions, please, like I said, feel free to throw them in the Q&A. You can always go a few minutes over if we need to, if there's any questions. Otherwise, you can find me pretty easy. My email is simba@featureform.com. And Shab, anything I missed?
No, I'll also be sending out an email to everyone that includes a link to the recording, a link to our community, and also ways to stay in touch with us.
Great. I'll leave like another minute or two if there's any final questions. And Shab, are there any questions on LinkedIn or Twitter? If there are any, just feel free to put them in the Q&A here, and I'll answer them as well. Great. So, like I said, easy find. If there's any last minute questions, throw them in. If not, that's totally fine too. And hope this was useful, and hope to see you at the next one. Awesome. Gonna end it here. Thanks.